Good day, guys. This is your tutor engineer. Today we are continuing with our series on geometry. Let's start with today's lesson. Use the given diagram to prove the theorem that states the angle subtended by an arc at the center of a cycle is double the size of the angle subtended by the same arc at the circumference of the cycle. So basically the question is asking us to prove that angle O is equal to 2 times angle M. Okay, to start proving this theorem, we need to draw an imaginary line cutting across O and M. Then we'll name this angle O1, angle O2, angle M1, angle M2. And then the first thing we must realize is that KO is equal to LO is equal to MO. They are all ready. So since we are dealing with the radius, so we'll say KO is equal to OM. The reason is ready. Therefore, we can conclude and say angle K is equal to angle M1 since KO is equal to OM. And then another thing we need to realize is angle O1 is the exterior angle of a triangle. It's equal to the sum of angle K and M1. So here we'll represent it as angle O1 is equal to angle K plus angle M1. The reason is exterior angles of triangle. So since we've already established that K and M1 are equal, that means you can replace K by M1, and then we'll have O1 is equal to angle M1. So let's just leave it here for now. We'll come back to it. And then likewise, we'll do the same. We'll say LO is equal to MO. The reason is ready. And then from that, we can deduce that angle L here is equal to angle M2. Angle L is equal to angle M2. The reason is LO is equal to MO. And then we can likewise see that angle O2 is equal to the sum of angle L plus and angle M2. So we'll say here O2 is equal to angle L plus angle M2. The reason is exterior angles of triangle. We've established that angle L and M2 are equal, so we can easily replace angle L by M2. Then you'll have 2 angle M2. Now angle O, right? Remember what you're supposed to prove. You're supposed to prove that the whole of angle O is equal to the whole of angle M. So let's write angle O in terms of angle O1 plus angle O2. It is equal to, let's replace O1 by 2M1, and then O2 we've established that it is equal to 2M2. Here we can take a common factor of 2, then you'll have M1 plus M2, right? So we can just replace this and say all of that is angle O and all of this is angle M. Then we have proven the theorem. This is the proof. Okay, now let's move to the second part of this question. Now I'll show you on this part of the question how you apply the theorem that we've just proven. Okay, so let's read first. In the diagram below, O is the center of the cycle. A, B, C, and D are points on the circumference of the cycle. EOA is a straight line such that E lies on BC, AD is equal to AB, and A1 is X, right? So this one is X here. The first question is calculate the value of B1 in terms of X. All reasons must be shown. So this is the angle that you must represent in terms of X. So let's quickly do that. Okay, remember, you're supposed to apply our theorem which says O1 is equal to 2 B1. Let's write this one down first, right? This one is always true. And then from there on, we know that angle A1 plus angle O1 plus angle D1, their sum will be 180 degrees. So let's write angle A1 plus angle O1 plus angle D1 is 180 degrees. The reason is the sum of the angles of the triangle. Okay, so since OA and OD are ready, we can establish that D1 is also equal to X. Okay, so let's write it and represent it as AY is equal to D1, which is also equal to X. The reason for that is OA is equal to OD since they are both ready. Okay, so we can go back to that we've written there. Let's just continue that part here. Therefore, we can replace both AY and D1 by X and say A1 will replace by X, likewise with D1. Then we'll have it's equal to 180. So we can say here 2X plus O1 is 180. Then you can comfortably write O1 as 180 minus 2X. Okay, now we've written, remember, we've already established this one. We've proven it on the first question. So let's replace O1 by 180 minus 2X. So we'll say 180 minus 2X is equal to 2 angle B1. Then we'll start dividing every term by 2. Then B1 will be 90 minus X. So that would be the first question, 9.2.1. And then the second question, 9.2.2, show that AE bisect BAD. So here is AE, here is BAD, right? So we just need to prove that A2 is also equal to angle X, and then AE would bisect angle A in that case. Okay, now let's prove that. Let's write 9.22. We can say the whole of angle A, right, which is A1 plus A2 plus angle B1 plus angle D1 plus angle D2, which is the angle D, is equal to 180. Reason is sum of the angles of the triangle. And then from there on, remember what you're trying to achieve. You're trying to say that we're trying to prove that A2 is equal to X, Okay, now let's continue. Let's continue to say angle, sorry, let's continue to say angle A1, right? So okay, we can see the relationship between B1. There's a relationship between B1 and D1 plus D2 since we're given that AD is equal to AB, right? So let's say angle B1 is equal to D1 plus D2. What's the reason? Because we're given that AD is equal to AB, right? Remember, we've established that B1 is equal to 90 minus x. That means D1 plus D2 is also equal to 90 minus x. So let's come to that equation and make changes to it. Remember, A1 is x, already we know that. A2, that's what we're trying to establish. B1 is 90 minus x. We've proven that on the first question. And then D1 plus D2 is also 90 minus x. We've just proven that. Then we'll say all of that is 180. So this x and that x will cancel out, right? So we're remaining with, on the left hand side, angle A2 plus 90 gives us 180 minus x is equal to 180. So 180 and 180 will cancel each other, and then you'll have A2 is equal to x, which is equal to A1. Therefore, we can conclude that AE bisect angle A into two equal halves, right? So we can just make that conclusion there. Okay, now let's go to question 9.2.3. Show that CEOD is a cyclic quadrilateral. Okay, so here is CEOD. So a cyclic quadrilateral has this property. It means this angle is equal to that angle. So if you can prove that angle O1 is equal to angle C, then we would have proven, would have answered the question. Okay, so the first thing we can do here, since we don't have sufficient space, let me just try and make it a bit smaller to make up for space. Okay, so that you can all see. I'll write 9.2.3 here. We can say angle C plus angle A1 plus angle A2, they're equal to 180. What's the reason for that? They're the opposing angles of a four-sided figure, right? Of a four-sided figure. So basically, let's choose a color now which is different. That angle plus this angle must give me 180 degrees. Okay, so with that knowledge, since I know that angle A1 is equal to angle A2, they are both equal to x, I can replace both of them by x, and then I will get angle C is equal to minus 2x, right? So you can see angle C is equal to angle O1. Remember from the first question, we've proven angle O1. So we can just deduce that angle C and angle O1 are equal. Therefore, we can make the conclusion to say CEOD is quadrilateral, or we can say is cyclic quadrilateral. That's it for today's lesson. I hope you enjoyed today's lesson. If you did like it, please subscribe and stay tuned on the next lesson. We'll meet you later. I'll meet you later. Cheers.